Hello, everyone, and welcome to our Fellows Public Talk series. I'm Claudia Rizzini, the Executive Director of the Fellowship Program at the Radcliffe Institute for Advanced Study at Harvard. It is my pleasure to introduce Sabine R. Huebner, our William Bentinck-Smith Fellow this year. Close your eyes for a moment and imagine a society handling simultaneously political instability, inflation, wars, a major disruption to daily life by a pandemic, and a worsening climatic condition. Honestly, how many of you imagine 3rd century Egypt? As the saying goes, history does not repeat itself, but it does go in cycles. Scholars like Sabine are key to deciphering the details throughout ancient history that parallel our own modern era. Sabine's research, focusing on Egypt under the Roman Empire, has made major contribution to understanding daily life in the ancient Roman Empire, including marriage, family structure, and adoption of Christianity. Now, in her current project, she's looking at the ways climate change and pathogen spread shaped Egyptian life and threatened the Roman economy during this critical period. While at Radcliffe, Sabine is working on a monograph synthesizing historical, archaeological, papyrological, and a variety of paleoclimatological data to draw attention to the ways in which climate change has shaped human society through history. She hopes the project will inform discussions of our current climate crisis by highlighting the patterns in our global past. The Q&A portion of the public talk today will be moderated by Daniel Immerwahr, Bergen-Even Professor in the Humanities at Northwestern University and Fellow at the Radcliffe Institute. And now please join me in welcoming Sabine Huebner.
Thank you, Claudia, for the introduction, and welcome to everyone in the room and to those joining us on Zoom. I've often been asked here what inspired me to study classics. It was a trip to Rome when I was 12. I usually hated city tours as a child, but that first visit to Rome left such an impression on me that in hindsight it wasn't only career-defining but life-defining. The pivotal moment was a walk with my parents and siblings along the ancient Via Appia, one of the oldest roads where the original cobblestone pavement still survives. Since I don't have a photo of that moment, I asked ChatGPT to visualize it. I had just started studying Latin a few months earlier, and I was struck by the thought that right there, on those very stones, famous Romans, like Cicero and Caesar, had walked, along with countless ordinary people, Roman women and Roman children, standing where I was standing. Moreover, the road where we had a picnic was lined with tombs dating back over 2,000 years. That was when I decided that I want to study the lives of the ancient Romans. Back then, I imagined a career in ancient studies to be a never-ending adventure, like in Indiana Jones films, filled with secrets to uncover and grant discoveries. Had someone told my 12-year-old self that the classicist workplace looked as it does, I might have reconsidered my career choice. No major new discoveries of source material were expected anymore. The 19th century had brought us the treasure of Greek and Latin inscriptions from all parts of the Roman world, while the late 19th and early 20th century had yielded the extraordinarily rich papyrus finds from Greco-Roman Egypt. Now it was about meticulous analysis, developing new interpretations of familiar material. Large leaps in knowledge and entirely new sources about antiquity were no longer expected. Instead, the focus was on defending the status quo and justifying the field's place in the already undervalued humanities. The natural and medical sciences had taken center stage. Why, some ask, should tax buyers fund the study of dead languages or yet another history of ancient Rome? I fought that battle gladly by turning my attention to topics that had previously been largely neglected, ones that promised relevance to our society today and its challenges. For example, I focused on researching the lower social classes, those who were not at the center of historical accounts, often not even mentioned, yet made up 95% of ancient population. I dedicated myself to reconstructing the lives of the rural peasants, of women, children, widows, orphans, the elderly, the weak, the poor, and those on the margins of society, using sources that had been largely overlooked. I wrote books on the Christianization of the Roman world and explored what it was about the new religion that fascinated people beyond promises of salvation in the afterlife. In other books and collections, I examined family structures among the lower and middle classes, household forms in both rural and urban areas, marriage ages for men and women across social classes, and I researched life expectancy and fertility rates in antiquity. I also wrote about access to education for women and girls, literacy levels in ancient societies, intergenerational relationships, and various forms of elderly care in the absence of state systems. Yet, I secretly regretted not being born 150 years earlier, in the age of great discoveries, though I harbored no illusions. I knew that back then, as a woman, I likely wouldn't have had the opportunity to study, let alone obtain a professorship. Then, a few years ago, the unimaginable happened from a completely unexpected direction. The natural and medical sciences began to take an interest in our research. Not only did they suddenly want to collaborate closely with us, but they also started providing us with a wealth of new data on the ancient world. Data we had never dared to dream of. The recent revolution in the so-called paleosciences, driven by advancements in ancient DNA analysis and climate reconstruction, has begun to transform our understanding of ancient history, providing unprecedented insights into the interactions between ancient societies and their ecosystems. Climatology had traditionally focused on Earth's deep history. Notable climate epochs included the Pleistocene, with repeated glacial and interglacial cycles, the Miocene, with global cooling trends, and the very warm Cretaceous Paleogene greenhouse climate during the age of the dinosaurs. In recent years, however, enormous advances have enabled climatologists to provide detailed data on climate developments over the past 12,000 years of the so-called Holocene. For the first time, climatology can now capture even finer fluctuations over shorter time spans, down to individual years or even specific seasons. These advances have yielded groundbreaking insights into the climate of antiquity as well. To contextualize these findings historically, climatologists rely on us as historians. These climate reconstructions allow us, for the first time, to link environmental changes with social, political, and economic shifts, showing, for example, how climate fluctuations affected migration, food supply, and the stability of ancient societies, topics especially relevant to us today as we address the challenges of the current global climate crisis. These climate data offer a new perspective on the ancient world, adding a new dimension to our understanding of history and introducing another factor to consider. Recent interdisciplinary research on the Greco-Roman and medieval periods have unveiled critical insights into how climate influenced societal transformations, economic shifts, and even the rise and fall of empires. A recent study has, for instance, provided new insights into the environmental factors that may have contributed to the migration period, which occurred roughly from the 4th to 6th century CE and was characterized by large-scale movements of various groups across Europe, including Goths, Huns, Vandals, later Slavs, and Lombards. Tree ring records, lake sediments, and ice core analysis from this period reveal a series of significant climate fluctuations. Some theories suggest that worsening climatic conditions in the steppes in the 4th century CE possibly due to drought, pushed the Huns from the Central Asian steppes westward in search of new grazing land for their herds. As the Huns advanced into Europe, they exerted pressure on Germanic tribes, triggering a domino effect of migrations. The Huns' movement westward prompted the displacement of the Goths and Vandals, who in turn moved into Roman territories. This movement put immense pressure on the Roman Empire's northern and eastern borders, as tribes sought either refuge or new territories with more fertile land and favorable climates. The other field that has perhaps even more impressively begun to revolutionize the study of ancient history is ancient DNA research. Ancient DNA research is interdisciplinary, bridging natural sciences and biomedical sciences. It extracts and analyzes genetic material from ancient samples, humans, animals, and plants. Originally driven by advancements in genetics and molecular biology, ADNA analysis offers entirely new insights into ancient societies, complementing classical methods in archaeology, history, and anthropology, and sometimes even challenging their conclusions. Ancient DNA research is equally a very young discipline that has only become established in the last 10 to 15 years. For instance, the discovery of Neanderthal DNA has opened remarkably new perspectives on human evolution and our relationship with other hominins. In 2010, scientists successfully sequenced the Neanderthal genome, revealing that Neanderthals were not simply a separate branch of the human family, but actually interbred with anatomically modern humans. And a recent discovery that made headlines only last week, involving also Harvard scholars, showed how new DNA evidence is rewriting long-standing assumptions about people in ancient Pompeii. When Mount Vesuvius erupted, it released deadly gases and ash, which slowly killed much of the population. The ash and volcanic rock then covered Pompeii and its residents, preserving haunting scenes of the city's destruction like a time capsule. Archaeologists have long interpreted stories from the plaster casts later made of the bodies that you see here, such an adult with a bracelet holding a child, believed to be the child's mother. Similarly, a group of bodies found together were thought to be sisters. However, this new ADNA study was able to challenge some of the previous narratives built around how these individuals were found in relation to one another. The researchers found that the person assumed to be a mother was actually a man, unrelated to the child he was holding. And one of the two people, thought to be sisters, was also a man. Their findings were published last week in the journal Current Biology. We are currently witnessing a revolution of unprecedented scale in our field, one that could, in the long run, overshadow the great discoveries of previous centuries. These synergies and interdisciplinary collaboration between geneticists, archaeologists, historians, and climate scientists provide us with brand new holistic perspectives on the past that go beyond the traditional boundaries of individual disciplines and also offer valuable insights for addressing today's global challenges. Today, I would like to share insights from my ongoing research on climate change and pandemics in antiquity. More specifically, I aimed to untangle the extent to which climate change contributed to the crisis of the Roman Empire in the 3rd century CE and to the spread of new diseases and the occurrence of pandemics. At its peak in the 2nd century CE, the Roman Empire was a vast, multicultural empire of unprecedented scale. The empire's population benefited from a peace that had lasted for nearly 200 years. Agriculture, one of the most important sectors of the ancient economy, flourished and was able to feed the growing population. Wealth was increasing across the empire. By the beginning of the 2nd century, the empire had also reached its greatest territorial extent. Thanks to their military successes, the Romans controlled 3 continents, including parts of Asia and Africa and most of Europe. A large portion of the world's population lived within its borders. The Roman Empire stretched from North Africa to Britain and from the Strait of Gibraltar to the Near East. Globalization reached an unprecedented height. thousands of kilometers of Roman roads crisscrossed the empire, allowing legions and civilians alike to travel in ways never seen before, while thousands of ships sailed the Mediterranean. Trade was not only flourishing within the Mediterranean. Routes extended as far as India and China, the Eurasian steppes, Central Africa, and even the North Sea. The political situation was stable, and the arts and cultures of the Roman Empire reached their peak. Architectural marvels like the Roman aqueducts, the Colosseum, and the Pantheon have survived to this day. Please take this with a grain of salt, though, as I'm speaking in very broad terms here. Of course, there were local wars and border conflicts, inequalities, exploitation, poverty, and slavery. It is more accurate to view the 2nd century as a peak of imperial power and stability rather than a universally golden age. Recent research suggests that climate factors may have also contributed to this period of prosperity. Paleoclimate research shows that climate during ancient Greek and Roman times was constantly shifting, though not due to human activity and not to the extent we've seen in recent decades. This graph illustrates that the 2 millennia before the Common Era were significantly warmer than the 2 millennia of the Common Era, which might be surprising, and that the period from the 15th to the 19th century was considerably cooler than the Roman period, and even the coolest of the entire Holocene. You can also see the remarkable rise in temperatures since the mid-20th century, which dwarfs any climate changes of the past 12,000 years. This recent temperature increase is the most striking climate feature since the last ice age. The Roman Empire grew from a small city-state to a world power during a period of relatively warm, wet climate, conditions that were essential for agriculture. The Mediterranean climate 2,000 years ago was nearly as warm as it is today, but had much more rainfall. Climatologists have called this period the Roman warm period, dating its beginning to around 200 BCE, coinciding with Rome's expansion beyond Italy into other Mediterranean regions. However, by the mid-2nd century CE, Rome's luck began to wane. Climate data from various parts of the Mediterranean suggest an increase in droughts and a drop in temperatures. All of these were detrimental to wheat crops, olives, and vineyards. Many researchers believe today that the importance of climate and other environmental factors in Roman history has been undervalued so far in historical studies, though we must also be cautious not to overemphasize them. As we embrace these exciting new data, it's essential not to overlook the critical methodology of the historian. We must avoid slipping into climate determinism and continue to carefully weigh cause and effect, correlation and causation. Regional case studies are essential to trace the specific impact of environmental change on societies. Having worked on the Roman province of Egypt for many years, I turned my focus to this region as a case study. Egypt became a Roman province in 30 BCE after the defeat of Queen Cleopatra VII and Mark Antony by Octavian, who later became Emperor Augustus. The Nile, one of the world's great rivers, along with its fertile floodplains, provided a key pillar of Roman economic stability in the following centuries and helped fuel Rome's imperial expansion. Egypt's status as one of the Roman Empire's most prosperous provinces stemmed from its enormous grain exports to the city of Rome and the Roman military stationed at the borders of the empire, solidifying its role as Rome's metaphorical breadbasket. Given the crucial role of Egyptian agriculture, it is surprising that most of Egypt is barren desert, receiving only a few millimeters of rain a year. This NASA satellite image illustrates the situation well, showing a narrow green strip of agriculture and human habitation along the Nile, culminating in its vast delta. The waters of the Nile make life possible in the desert by providing irrigation and fertile soil along its banks. The Nile's annual summer flood naturally varies in timing and volume each year, shaping the agricultural cycles and livelihoods of those who depend on its waters. The extent of annual flooding of the Nile depends considerably on rainfall patterns in the Ethiopian highlands, which are strongly influenced by the East African monsoon regime. Increased rainfall in equatorial East Africa leads to higher Nile discharge. Other factors include solar cycles, summer insolation at low latitudes, sea surface temperature variability in the Pacific, and volcanism at high latitudes. The success of an agricultural year in Egypt was determined partly by the height of the Nile summer flood and partly by its timing. A flood that started too late and stayed too long on the fields prevented timely planting. If the flood was too low, the higher fields could not be irrigated. Conversely, a flood that was too high endangered infrastructures such as dikes and villages themselves, and also lasted longer before receding and clearing the way for sowing. The unpredictable summer floods of the Nile are already mentioned in the Old Testament in Genesis, which relates the dreams of the Egyptian pharaoh. This episode aptly illustrates the need to make provisions for times of famine in years of plenty, and the vital importance of flexible government administration in response to Nile's vagaries. The uncertainty of Nile flooding was also the main reason for building the first Aswan Dam in Egypt in the early 20th century, where a growing population accentuated vulnerability to periods of low Nile water levels. The aim of the dam was to limit these risks by ensuring constant regulated irrigation of Egyptian fields, thus stabilizing agricultural productivity independently of natural fluctuations in river levels. It was a strategic response to address the critical balance between natural water cycles, which however led to a whole series of other environmental problems. In 2021, I was awarded a major grant from the Swiss National Science Foundation for a project entitled the Roman Egypt Laboratory: Climate Change, Societal Transformations, and the Transition to Late Antiquity. Today's presentation highlights one of the first results of this project. My goal was to reconstruct the degree of variability of Nile flooding during the Roman period and to identify years of reduced flow. As the Egyptian economy depended on the recurrent flooding of the Nile, changes and irregularities in the water supply could affect the quality and quantity of fertile land and agricultural production. Uncultivable land jeopardized both wheat supplies and tax revenues to the Roman state. Thereby, I believe to have found a proxy, not only for Egypt's agricultural productivity, but also for years of prosperity or shortages within the Roman Empire in general. While Rome could compensate for crop failures in Egypt by sourcing grain from North Africa and Sicily, the repercussions of such failures would undoubtedly be felt elsewhere, manifesting themselves at the very least in high grain prices. Reconstructing the annual quality of the Nile floods would thus provide me with an indicator of the overall economic prosperity and socio-political stability of the empire. I also wanted to know whether and how the Roman government decided to respond to environmental changes and disasters and actively promoted agricultural resilience and sustainability in Egypt. Let's begin by looking at the types of sources we have to reconstruct annual Nile flood patterns for the Roman period. Nilometers were used to measure the annual flood levels of the Nile. Nilometers often consisted of a stone column, stairs, or a deep well with graduated markings, and connected to the river through tunnels or channels. The measurements from these nilometers determined the taxes that could be levied on areas impacted by the Nile. Numerous nilometers were constructed along the Nile, and from as early as the Old Kingdom, priests measured Nile levels initially at the southern border of Egypt, where the first floods typically arrived in late summer. These measurements were then relayed north to Lower Egypt, allowing authorities to implement water distribution rules and set taxes on farmers early in the flood cycle. Most of our knowledge about Roman Nile flood levels comes from papyrological evidence. Papyri, ancient documents written on paper-like material made from the papyrus plant, were widely used in classical antiquity for administrative, literary, and personal texts. These documents provide valuable insights into daily life, the economy and culture of the ancient world. Because of Egypt's dry climate, many papyri have survived in the desert sense. Among them, text notices or declarations submitted to tax authorities are particularly informative, showing the Nile flood's impact on agricultural production. The taxation rate adjusted each year according to the intensity of the flood and the extent of land inundation. Occasionally, Roman historiography provides additional insights into Nile floods. Although these accounts are rare, they are exceptionally valuable for our reconstruction efforts. Roman accounts of the Nile's flooding, or the lack thereof, are often intertwined with imperial events, making them easy to date. Occasionally, also numismatic evidence is of relevance. Apart from historical sources, I also examined paleoclimate proxies for Nile floods during the Roman period. For instance, sediment cores, which are cylindrical samples extracted from the Nile Delta, the Fayum lakes, the Nile riverbed, and lakes in the Ethiopian highlands. These cores preserve traces of ancient vegetation, pollen, minerals, and isotopes, which reveal environmental conditions and changes over long periods. However, sediment cores do not provide detailed information on an annual or even decadal basis, but rather over longer stretches of time, and I was particularly interested in annual resolution. Initially, I therefore had high hopes for the substantial amounts of ancient wood preserved in Egypt's dry desert sands. Archaeological wood can reveal past climate conditions through growth rings, as variations in ring width and density reflect factors like temperature, rainfall, and seasonal changes over the tree's lifetime. Egypt's unique preservation conditions allow for a remarkable collection of ancient wood compared to other Mediterranean sites. However, it turned out that locally grown wood in Egypt, primarily acacia, ficus, and tamarisk, do not form visible tree rings, making it unsuitable for climate reconstructions. While we found large quantities of imported wood, this only reflects environmental conditions where the tree grew and will thus be the subject of a new project in the future. Another relevant natural proxy for reconstructing Nile flood levels are ice cores, which serve as frozen time capsules. Ice cores, cylindrical samples drilled from glaciers or ice sheets, mostly in the Arctic and Antarctic, preserve layers of ice which trapped air bubbles, dust, and isotopic variations. These provide detailed records of past atmospheric composition, temperature, and climate change over hundreds of thousands of years. Ice cores, especially those with precise dates, also record the chemical fingerprints of past volcanic activity. Why, you might ask, is this relevant? Volcanic eruptions can cause short-term climate changes by releasing sulfur dioxide into the stratosphere, forming sulfate aerosols that reflect sunlight, cooling Earth's surface. This cooling effect, lasting months to a few years, lowers global temperatures and can disrupt weather patterns. Relevant to my study, volcanic eruptions can also provoke a physical response from the Nile. When sulfur is injected into the stratosphere, resulting lower global temperatures weaken the East African monsoon, reducing rainfall in equatorial regions like the Ethiopian highlands, the main source of the Nile summer floodwaters. Consequently, Nile summer flooding may be suppressed for 1 or 2 years following an eruption. The results gathered from various sources are summarized in this table. As you can see, I provide data for about half of the recorded years. For the remaining years where we don't have direct evidence, it is reasonable to assume that the Nile flood was likely normal, stable enough not to warrant any special mention in the surviving sources. However, as the saying goes, the absence of evidence is not evidence of absence. Just because we don't have records doesn't necessarily mean nothing significant happened. It simply means that those moments left no trace in the sources we rely on today. My reconstruction of Nile flood levels during the Roman period reveals not only year-to-year variations, but also a significant downward trend in Nile discharge over the Roman period in Egypt. The tipping point appears to have occurred sometime during the reign of Emperor Hadrian. Interestingly, this decline in the Nile's strength seems to coincide with a cooling climate across the rest of the Mediterranean and the end of the Roman warm period, a matter that requires further investigation in the future. This detailed year-by-year reconstruction of Nile flood levels during the Roman period allows us not to directly correlate environmental changes with economic and social dynamics in one of the empire's most vital provinces. These findings on the decreasing Nile flood levels during the Roman period correlate with papyrological and archaeological sources, indicating an increase in water stress and a decline in settlement in regions of Middle Egypt, particularly near the desert, from the late 2nd century onwards. In a recent article in Studies in Late Antiquity, I argued that water stress was a key factor contributing to the decline and eventual abandonment of formerly prosperous agricultural towns in Middle Egypt. The papyri offer a wealth of information on how a Roman village coped with environmental changes and the relentless advance of the desert. Here we have a petition of a Roman village from 323 CE, which survived on papyrus and encapsulates the village's difficult situation. I quote, "We receive no water to irrigate our fields, and due to the very fact that the village lacks water, it has been paralyzed. We have been reduced to poverty by paying fees for so many fields not flooded for a long time. You ordered the dike inspectors to visit the locality accompanied by a member of your staff and inspect the premises. And they came and discovered that we were receiving no water, not only this year, but for many years. The remaining inhabitants, instead of leaving to seek better conditions elsewhere, did not submit passively to their fate. They adopted a range of coping strategies. They appealed to local governors, shifted from crop farming to grazing, and sought relief from their tax burdens. After decades of struggling against relentless drought and the challenges of a changing climate, the village, however, was ultimately abandoned, along with several other settlements on the desert's edge." I would like now to explore whether and how the Roman government responded to these environmental challenges, particularly the series of below-average Nile floods that became more frequent from the 130s CE onward. My presentation aims to provide a first step in examining the complex relationship between climate variability and local governance in this context. Let's consider just one case study. Papyrological evidence shows that in the final years of his reign, Emperor Hadrian had to respond to environmental challenges caused by low Nile floods. To address this, he issued an edict in the spring of 136 CE, allowing Egyptian farmers to pay their taxes in installments. This edict, preserved on a papyrus found in the Fayum, also conveys Hadrian's optimism that better years would return. Hadrian states, "Learning that this year's Nile flood is lower than normal, reflecting last year's trend, despite the fact that previously it had not only been ideal but even higher than ever, leading to excellent and abundant harvests, I resolved to provide some reliefs to the farmers. However, I trust, invoking God's will, that in years to come, if a deficit occurs this year, the Nile will flood the land again and regenerate its fertility." In general, my research also of other case studies show that the imperial bureaucracy responded effectively to environmental crises, attempting to mitigate impacts through tax reliefs and fiscal incentives to restore unproductive land to cultivation. Taxes were adjusted based on Nile flooding and irrigation status rather than crop yields, supporting sustainable agriculture with maximum profitability. This system enabled farmers to retain control of their surplus without increased tax burdens. However, this system worked best in centuries with relatively stable, abundant Nile floods. From the mid-2nd century onward, Egypt faced increasingly frequent suboptimal Nile floods, sometimes even long stretches of bad years. This reduced water supply led to poor agricultural yields, depleted grain reserves, severe food shortages, and soaring grain prices, resulting in widespread famine and malnutrition. A gradually shifting climate from the 2nd century onward not only led to an increasing number of crop failures and famines, malnutrition also made the empire's population more susceptible to all kinds of diseases, including new ones. Globalization had brought great wealth, but now it also brought previously unknown pathogens into the empire. The end of this prosperous era and the Roman warm period coincided, perhaps not by chance, with the first pandemic in human history, which swept across the entire empire in the mid-2nd century CE. Modern historians have named this plague after the reigning emperor Marcus Aurelius Antoninus, the Antonine plague. According to Roman historiography, the plague first broke out in the eastern provinces. Roman soldiers fighting in Mesopotamia reportedly contracted the virus there and brought it back with them to the Mediterranean region. Released into the densely populated and interconnected Roman Empire, this new pathogen had devastating effects. Today, we understand the direct link between trans-regional trade, urbanization, and the spread of infectious diseases. The extensive network of roads and ships that transported goods and people also allowed viruses and bacteria to spread throughout every corner of the empire. Contemporary sources tell us that the plague spread like wildfire. The result was mass deaths, which only brief interruptions persisted for over 15 years, leading to widespread depopulation throughout the empire. During this pandemic, in the Roman province of Egypt, a middle-aged man named Stothoetes walked into the district office of his regional capital to file a desperate complaint. His house had been seized by someone in his absence. The report he filed, preserved for nearly 2,000 years in the arid sands of Egypt, reveals a heartbreaking story. Stothoetes reported the theft of his house, but almost in passing mentioned the death of his wife, his 2 daughters, and his 2 sons-in-laws, the entirety of his immediate family. He noted that many others from his family and village had also perished in a matter of days. With no one left, Stothoetes had fled his village, leaving behind all his belongings. He survived by isolating himself for several days in the countryside. In an era where people didn't understand how diseases spread, Stothoetes acted on instinct, isolating himself to escape the invisible killer. His instinct saved his life. But his survival brought new challenges. In the aftermath of the pestilence, we glimpsed the darkest side of human behavior, individuals exploiting the chaos to seize property left behind by the dead or displaced. In the months and years that followed the initial outbreak, the pestilence spread to nearly every other corner of the empire. The Roman historian Ammianus Marcellinus reported, "Soon the plague spread throughout the land, from the border of Persia to the Rhine and Gaul, bringing contagion and death." The historian Cassius Dio also recorded death tolls in the capital. A plague arose, the greatest I've ever heard of, for in Rome sometimes 2,000 people died in a single day. The famous Roman physician Galen, summoned by Emperor Marcus Aurelius to help document the symptoms of the disease, he noted that the first sign of infection was a severe rash spreading over the body, which later became scabs. This was often followed by fever, diarrhea, and inflamed throat and bloody coughing, with some patients also experiencing nausea, vomiting, and bad breath. In about a quarter of cases, death occurred between the 9th and 12th day. Based on Galen's descriptions, the exact nature of the disease remains uncertain, but modern scholars suggest that the Antonine plague was likely a smallpox epidemic. Smallpox is a highly contagious disease caused by the smallpox virus. Today, thanks to vaccination, smallpox has been eradicated. The estimated mortality rates of the Antonine plague are still debated. Models suggest that in a population with no immunity to smallpox, like the Romans, and with a similar density to that of the Roman Empire, the death rate might have exceeded 30%. By comparison, the COVID-19 fatality rate in Western Europe was about 0.4% and 1.17% in the USA. This plague of the 160 CE was therefore a catastrophe of unimaginable scale. The Antonine plague was the first pandemic in human history and it may have even spread to Mesopotamia, India, and China. The Han Empire was also afflicted by several epidemics around this time, particularly a plague in 166 CE considered to be a universal pestilence in Chinese sources. The pandemic's impact was devastating and is thought to have marked the beginning of the decline of the Roman Empire. Interestingly, I discovered that a series of poor Nile floods preceded the outbreak of the Antonine plague in 165, and the second pandemic, 80 years later, the Cyprianic plague in the middle of the 3rd century. Connecting these two phenomena, a prolonged period of low Nile flooding and the onset of a pandemic, is part of my current research. The hypothesis is that famine and malnutrition caused by consecutive years of insufficient Nile flooding and worsening climate conditions around the Mediterranean may have weakened the population's immune system, making them more vulnerable to infectious diseases. Temperature fluctuations may have also played a role in affecting the disease vector itself. To confirm this, however, we would need to definitely identify the pathogen responsible for the pestilence. I'm working closely with ADNA researchers to analyze bone samples from various regions of the Roman Empire, including the Balkans, Rome, Central Italy, and Egypt, to identify the pathogen responsible for this pandemic and further explore whether its spread might have been influenced by climate fluctuations. This multidimensional approach highlights the complex interplay between climate, nutrition, and disease dynamics in historical contexts, a field of research that is still in its early stages. Many reasons have been cited for the severe crisis that became known as the crisis of the 3rd century, a period that nearly brought the Roman Empire to its knees. The pandemic's aftermath was certainly a significant factor. In the 3rd century, enemies poured all across the borders, penetrating deep into regions of the empire that hadn't seen war for centuries. One emperor after another ascended the throne only to be deposed and murdered shortly afterward. The unity of the empire disintegrated, with breakaway regions forming in Gaul in the eastern Mediterranean. Additionally, trade route collapsed, tax burdens increased, and after a failed currency reform, inflation reached unprecedented heights. When another pandemic struck in the mid-3rd century, claiming many lives, people looked for scapegoats. They found them in the Christians, who were persecuted as enemies of the state and blamed for the empire's woes. However, the Christian church not only withstood violent attacks, but also distinguished itself by caring for the sick and burying the dead amid the plague, earning respect and likely contributing to the success of the new religion. In the following years, Christianity grew faster than ever before. By the early 4th century, when Emperor Constantine the Great ended the persecutions and officially recognized and supported Christianity, it is estimated that already a quarter of the empire's population was leaning to the Christian faith. In recent decades, historians have proposed numerous explanations for the so-called crisis of the 3rd century, yet climate change as a factor was only recently introduced, spurred by advances in paleoclimatology, ancient DNA research, and a heightened awareness of current issues. Historians are, after all, products of their time. Colder temperatures, prolonged droughts, crop failures, malnutrition, global trade, newly introduced pathogens, and a weakened, vulnerable population may have contributed to the first pandemic in history. This so-called Antonine plague, which may have claimed up to 1/3 of the empire's population, had far-reaching effects on political stability, the strength of the Roman military, economic power, and social harmony. Today, we face similar challenges: climate catastrophes, a pandemic with significant economic and social consequences, and political instability. Moreover, forecasts suggest that by the end of this century, up to 2 billion people globally may be forced to leave their homes due to climate change and natural disasters. Climate changes likely played a significant role in the rise and fall of the Roman Empire. However, the changes the Romans experienced were minor compared to the climate crisis we face today. We are now dealing with unprecedented levels of climate change, bringing consequences that are both far-reaching and difficult to predict. What can we learn from the Romans? Roman history reminds us of the power of nature and our vulnerability to uncontrollable natural phenomena. The new findings from paleoclimatology and ADNA research underscore the importance of environmental and biological influences on historical processes. allowing us to see Rome not just as a political and cultural phenomenon, but also as a society, deeply interconnected with and shaped by its natural environment. Climate change and pandemics greatly weakened the Roman Empire and may have even contributed to its collapse, parallelly to a range of other factors. This awareness of how environmental shifts and disease outbreaks can destabilize societies should inspire today's policymakers to initiate bold, timely reforms. Thank you.
Sabine, that was an extraordinary presentation.
Thank you, Daniel.
Lucid, wide-ranging. Thank you. That was wonderful. I want to first ask about your own journey. You described your field as having gone from being a textual field, certainly concerned with archaeology, but one that I had thought of as being really anchored in the humanities, to being sort of blindsided by the sciences. And I'm wondering what that was like in your own career. Did you have to learn new skills? Is this done through collaboration? Tell me about that.
Yes, of course, that is a very good question. For me, it started about 10 years ago when I learned about the advances made in climatology and ADNA research and how these fields were suddenly studying also my period and my regions under study. And there was an interest, but of course in the beginning there were also a lot of complications in collaborations because the natural sciences and the humanities use different terminology. They have very different methods. They work on very different timescales. There are no funding tools, that we could use to collaborate more extensively together. So in the beginning for me, it was inviting those scholars, to workshops, to just sit together and to introducing our fields to one another, explaining what we are doing, where our data comes from, what are the challenges in our data, the uncertainties in our data, and how we reach conclusions so that not the climate scientists would just naively use a historical source to explain what they see in their data, or that we access their raw data without having a deeper understanding what it means and where the uncertainties are.
Yeah. So obviously you mentioned that you're working on different timescales, you're working with different sources of data. Have there been either difficult or productive methodological tensions as your field tries to scientize?
Yeah, and especially with paleoclimatology, I discovered many similarities because we as historians, we work with archives, like papyrological archives, and they all archives made by humans. And the paleoclimatologists also work with archives. They have the same approach, but their archives are made by nature.
Yeah.
And so the concept is very similar. And, like one could even consider them now as another subfield of classical studies, because they are just looking at a different kind of sources as us. It's very different with ADNA research, which kind of they are, how should I say that, like they're putting upside down what we have thought for so many years.
This is what I wanted to ask about. So, how far do you think you are in the sort of perspectival shifts that come with the ADNA research and the climate stuff?
Yeah.
Do you feel like your field recognized some new questions, data, and is dealing with them? Or do you feel like new research is continually challenging what you know and will continue to do so?
For now, not many ancient historians have, been open enough to work with this new data, and it's very time intensive even to start a collaboration with these fields. And I found it particularly productive working with climatologists, while ADNA research is just changing the way we have looked at ancient societies, We have claimed certain things, and ADNA now presents us new results.
Yeah.
And this is what it is. While with climatologists, we can still argue, okay, that didn't have an effect, but look at that, There were droughts, but there were imperial measures that counterbalance that. ADNA now tells us, okay, this was not a mother holding a child, that was a man, and he was not related to the child. It was like that, like annihilating, decades of archaeological research. And I could cite many other examples. And, but they are doing such important work, which will also help us for the future, like even in the spread of pathogens, the history of pathogens, like human migration, and all these things, the most is still to come.
Yeah. So I'm also a historian, and I'm doing a different period where the same questions have arisen. Suddenly we are really interested in the Little Ice Age and how it shaped early modern societies. And a question that arises is, how conscious were people then of climate change? Surely they were aware that the weather changes sometimes, and you can get droughts and you can get good years. But what kind of sense do you have that people had some sense that there could be larger shifts that weren't just sort of the seasonal or yearly fluctuations, but that might be on the order that, in fact, they were living through?
Yes, we see that in the way like the ancient people adapted to climate fluctuations. I'm sure they didn't have an awareness, that there was global climate change happening, maybe at the end of the Roman warm period. However, they saw that the olives didn't grow so well anymore, and that they switched from olive growing to wine producing, and when the wine didn't work out so well anymore, they let their cattle graze on this land. And we really see that, adapting to climatic fluctuations. And even that example that I brought from that Egyptian village, they had fought for many decades. They were very strong in wheat production in the beginning of the 3rd century. Then they switched to wine producing. In the end, they grazed their cattle until their village was entirely abandoned. Or people just returned in years with bad Nile floods until it was completely abandoned.
So, I guess one way to ask about this is, you had that imperial response. Yes, I understand there's been a bad year, but bad years are always followed by good years. So there's a kind of social insurance based into actually how the weather works. And what I'm hearing from you is that people become aware that an old strategy, a familiar strategy, might not just have to be put on pause, but might have to be abandoned, and perhaps abandoned very quickly.
Mm-hmm. So the example I brought from the Emperor Hadrian was a very early response to like a short succession of low Nile floods, where he says, look, there have been better years, there will be better years again, the Nile will restore its fertility. But this was just the beginning. Later we see other reforms at the beginning of the 3rd century, in the middle of the 3rd century, where emperors try to more desperately install reforms, bring back old productivity of Egypt, but eventually also recognize that Egypt was not such a stable economic partner anymore, where they sourced more grain than from North Africa or Sicily.
So, okay, this is a question that has just come up from our audience. One possible strategy to deal with a shortage, and a shortage that doesn't look like it's going to bounce back anytime soon, is to develop more long-term trade strategies. So you told a story about how the unreliability of the Nile leads to shortages, and that could explain pandemics. Can we also trace differences in trade networks based on the inability to source things in the usual ways?
Over the course of the 3rd century, I think I also mentioned in passing, all these trade networks that I showed on one slide, they broke down. There was intensive trade with the Red Sea and the Indian Ocean from the late 1st century over the 2nd century, which comes nearly to an end over the course of the 3rd century. And scholars have also tried to come up with reasons for this extreme decline in trade. And climate can be just one factor. We also have to always consider the whole picture. but it might have contributed to this, together with demographic loss and weakening borders, weakening of the Roman military, and so on.
Yeah. So you ended with, your presentation had a nice symmetry. You started with, here are present-day concerns and capabilities that shed new light on the past, and then you ended by saying, and what we've learned about the past might shed some new light on the present. And that's a move that historians often make. They want to suggest that somehow engaging with a distant time and place might give us some perspective. And I fully understand that one of the things that would do is to encourage us to realize how dependent our societies are on the backdrop of what we usually consider to be nature, and which in fact might not be a backdrop, which might be a protagonist itself. But I'm just wondering if you could say a little more about your experience as someone who works on the ancient past and thinks about it constantly, hearing the kinds of discussions that we have about the same set of issues. Are there frustrations? Are there rants? Are there things that you just keep wanting to shake people until they get? How do you react to the way that we talk about pandemic, disease, social stability?
Yeah, well, I think in the general educated population, there's a very good awareness of what is going on. So, and it is just supporting what we then discover about the ancient world, about the mechanisms, and what drove new diseases and the rising of new pathogens. We see many parallels to our today's society. So no, of course I don't get upset. I don't want to drop any names now of people who ignore these issues, but you understand what I mean.
Yeah.
Yeah.
In all of this research, both as you're absorbing the conclusions of collaborators and people who are sort of coming into your field in unexpected ways, and as you're doing your own research, what's surprised you the most?
What surprised me the most? In fact, in recent years, I think the relevance, again, of antiquity, and that we are dealing here with the first centuries of the human past, where we have enough evidence, to really study these questions that concern us so much today. Current challenges, and by going back 2,000-3,000 years, climatologists, ADNA researchers, they actually can work on concrete data to build models for the future. Yeah. That it is not completely irrelevant what we are doing, but actually very important.
And I'll say that one of the things that struck me so much about your talk was, you think, the kind of environmental variation that they were dealing with in the Nile is so much less than we are dealing with right now.
Yeah.
And I understand that we have other infrastructures that can protect us, but just, to follow your chain of hypotheses, to imagine, a bulky Nile triggering the fall of the Roman Empire, or at least great instability in the Roman Empire, you get very nervous about what's going to happen with far more rapid and far more extreme change.
It's quite creepy when you look at that, the climate change we are producing today. Yeah.
What a terrible note to end on. Sabine, this was absolutely wonderful. I want to thank you for a fantastic talk. I want to thank the audience for being here, for your questions. I also want to remind everyone that we have a number of Radcliffe virtual programs, and you can find out about all of these programs and watch videos of them at radcliffe.harvard.edu. Thank you so much for joining us.